right, can you take an expression that looks like this and split it up?
Yes.
Yeah. Question, can you go from the right side of the formula to the left?
Yes.
Okay. Question, if you go from the left to the right, are the expressions getting bigger or smaller? Bigger. Why? From a single log to a sum of 2 logs, true? So you're expanding. Good. What happens if you go from the right side to the left side? Condensing. So some of you, hey, write down your homework. Go team. All right, so we already talked about these properties can be used to simplify kind of confusing things. Like these two, there wasn't an explicit direction. You kind of just had to say 8 is 2 times 4, and I think that helps. This could be log of 9 minus log of 300. I can deal with 300, maybe not so much the rest of it. But sometimes they give you the explicit directions of, hey, expand it. Oh, I'm supposed to break it apart using the product property or the quotient property or the power property. But what we didn't get to do on Friday was the condensing. Well, I did show it to you really quickly, and I was asking you, does it make sense? So now that you look at it, condensing, going from the right sides of the properties to the left, does it make sense why this is the condensed single log from the difference of those two? Why? Why does it make sense? What would be the steps in getting to the answer? Some of you did get this, some of you didn't. All of you are looking at it now. Exactly, the 2. What can we do with the 2?
Put as an exponent.
We could put it as an exponent. So the in-between step is we could make this log of x minus log of x plus 1 quantity squared. Then we can use the quotient property to say, oh, hey, single log of a division. Now number 4, we'll see if it, or if it can trick you. But let me give you a second to catch up. Some of you guys, I don't think we really wrote down most of this page on Friday. Quick heads up, your test corrections are due this Friday. Section 3.3, sorry, is due tomorrow, but we are going on to 3.4 as well. Your calendar is a little off because I think I forgot Friday was a minimum day when I first set it up. So I will try to update your calendar by the end of the day so that it reflects what we're showing. But remember, the backboard is always up to date. Is the copy officially out?
Check.
Oh, I want to.
Lost my cups.
No more getting coffee during class. People need it to be earlier, but if we're out of cups, and that's the only reason why I do have them, you can get them after class. Bought a whole box of Smart and Fine. Alright, if you've written down letter B, you should be trying letter B. And I give you the final answer in just a second. You are allowed to ask in groups or check in groups. And I give the final answer in just a moment. My advice to you would be to do it step by step. But what would it be as fully condensed as possible? Keeping it legal. Remember, this entire chapter, we have lots of little puzzles, but we have to follow the rules. Our goal is to condense. Those of you chilling, I think you've already condensed. Check on your groups. You don't have to check the answer per se, check if they know what they're doing. Look at your properties, the ones that were just on the board. Look at your properties. I see addition, I see subtraction,
That's a 4.
I see multiplication.
Oh, I thought you meant
You can only do the properties with addition or subtraction outside of the LN. Just a quick heads up. Inside the LN, it's just stuck. There's nothing you can do.
Distribute the 4 in each room. I do minus 2, so these 2 together and then I know this one.
Yeah, it's because this would be Z to the 4th
Pause if you have not checked in your groups yet. Talk it out. There are only 2 groups I've seen that haven't really collaborated much, but maybe you do it silently.
So this is
On your marks. Get set. Check. Oops, check. Oops, check. There you go. How? Someone tell me how to start. Don't tell me the answer. I already wrote it down. How to start. Thomas, what would you do?
Yeah.
Okay. Okay, what else can you do besides bringing the 2 up with the power property of this guy? What's something else you could do? Andrew, what do you think?
We multiply the Z and Z plus 5.
Yes, you could. You could do that. What else could you do? So far I used the power property. So far I used the power property. Sorry, go ahead.
Do you put it to the 4th power then? The whole thing?
Ah, the whole thing. So ln of Z times Z plus 5, all raised to the 4th? So if it's all raised to the 4th, what does that mean? You could rewrite Z times Z plus 5 4 times. So how many Z's do you have? How many times have been multiplied together? You have 4 of them. How many Z plus 5s do you have? 4 of them. So you could write it Z to the 4th, Z plus 5 to the 4th, and the last step is the quotient property over Z minus 5 squared. Does that make sense? Some of you weren't quite sure if you could bring that 4 in. You might have thought that you were killing puppies. If worse comes to worse, just think. If you were to rewrite it 4 times, right? It's totally legal to say, oh, hey, both of them are going to be to the 4th power. If you were to rewrite it, Z to the 4th and Z plus 5 to the 4th. It's not killing anything. It's only killing something if you bring it into the parentheses, which we did. Yeah.
So if you distributed the Z and made Z squared plus 5Z.
Ah, that's illegal.
Okay.
Oh, never mind. If you distributed the Z first and then raised to the 4th, that would be legal. It would be the same thing. I just have mine more factored than you do, if that makes sense. I have mine more factored. So Z squared plus 5Z all to the 4th would have been equivalent. Mine's just all nice and factored. Okay, other questions? You guys see how it's just one big old puzzle? Just gotta figure out how to legally condense it. Okay, what else is this section? Ooh. No calculator, no calculatrice, no calculadora. You're welcome. How can we simplify without using a calculator? ln is e. Kind of, it's log base e, it uses e, but it's not e. What do you guys think? Expand, condense, or just magically get to an answer? Good. Expanding's a good idea because it's already been condensed. We need to break it apart. Those of you magically get to an answer? Well, a little sketch. Unless you know it's -1/2 because you're amazing like that. Anybody knows -1/2 just because you're amazing like that? No mental math? Okay. So if we were to expand, wouldn't it be ln of 1 minus ln of e to the 1/2? Maybe now you know where the 1/2 comes from. Couldn't you make it ln of 1 minus ln e to the 1/2 square root 1/2 power? How on earth are we supposed to simplify further?
Over now.
Yeah. We can do ln of 1 minus 1/2 ln of e. Isn't ln of e the same thing as log base e of e? Ooh, there's a property for that. What happens if we have log base a of a to the 1? They cancel, they undo, and all that's left is the power, which would just be 1. In question, any base to what power is always 1? Any log of 1 is always 0. Or we could rewrite it. ln of 1 equals, I don't know, let's figure it out. So e to the I don't know is equal to 1. Well, what has to be the power to make any base 1? 0. Yeah, you have to make it 0. So any log of 1 is always 0. That was one of the properties from last section? Maybe the beginning of this section? I think it was last section too, good call. Where the one-to-one property was. Section 3.2. So then at the end of the day, what did I say it was? Is that right? Is there another way of thinking about this without expanding? This was the expanding route. Wasn't bad. This was the expanding route. Wasn't bad. Was there another way of going? You guys can keep thinking. I'll just give you the hint. How could you rewrite this without expanding? Keeping it condensed. How could you rewrite it in a way that you could get to negative 1/2? Square root of e could be 1 over e to the 1/2, and how can we rewrite that? Ooh. Isn't it e to the 1/2 in a denominator, which we can say is a negative exponent? And so we can make it ln of e to the negative 1/2? Why is that cool? Could we have gotten there a whole lot faster? Log base e of e to the negative 1/2. The inverse property says it's just negative 1/2. But if you need to see it, you bring down the negative 1/2, and ln of e is just 1. Dun, 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 dun. That's how my brain works. But, does this way work as well? Yes. But do you still need to know that ln of e is equal to 1? Yes. So quick question. What if I was to ask you the following? Don't write it down. Let's just practice. Ready? Hope you good?
Yes.
He's missing his copy. Log base 2 of 2 cubed. What's that?
30.
Good. What would be log base 17 of 1 over 17? Negative 1. Ooh, why? 17 to the negative 1, log base 17 to 17 is the power. Nice. We're about to ask you, log base 3 of 1 over the cubed root of 3.
1, 0. Negative 1/3.
Put it all together. You guys kind of have to piece this.
Negative 1 and 1.
Negative 1/3. Why? It's a 1/3 power in the denominator, which I can make a negative 1/3. True? Well, if I was to ask you ln of the cubed root of e to the 5th. You got it. Close. 5/3. Remember? The whole number stays. That's on top. The root goes in the denominator. 5/3. What if I was to give you
It doesn't exist.
Good try. Not 2. Not 1. Trying to see mouth answers. Some of you are very quiet. Just mouth it. I'm trying to read your lips. Some of you are hiding your lips. That's not helpful.
2E.
Not 2E. Caroline. Yes. Oh my God.
Wait, what?
Yeah.
Why?
Because if you split it up.
You have to split it up. You cannot cancel the ln and the e. You have to split up to be ln of 2 plus times ln of e. And ln of e is just 1. Now, you can't combine the 2 and the 1 to make 3. It's ln of 2 plus ln of e, which is 1. So 1 plus ln 2 is the best way of writing it. Do you not see how it happened?
No, I don't understand LN.
Remember, ln is the same thing as log base e of e. So the same way that we were canceling out, like with these ones, we could cancel these ln of e out, but we have to keep the power. Hence why you have ln of 2 plus 1. Does that make sense? All right. Too much fun. I was just seeing how I could challenge your mental math skills with logs. Ready, set. Huh. Go. How far can you go? Go. How far can you go? Keep it legal. Some of you will try to go too far. Beware of going too far. There's a life lesson in that one. Beware going too far. Make sure that what you're doing is legal. But go as far as you can. Groups, collaborate, go! How far did you go? Did you get farther than anyone else? And did you do it legally? How far did you go? Was it legal?
It'd be like a square is 1 half.
No, it'd be ln minus ln x minus
Did you get the same as that?
Why don't they both determine
I'm not
How far did you go?
So you can take, no, you can't take out the extra. This is part of it. This is part of it. Not there. Remove it.
Question. Is there any other way of going? What could some people mess up? Some people would say, oh, that's x plus 1. What they kill?
Puppy.
A puppy. That does not factor to be x plus 1. That would be x plus I times x minus I. Not a good idea. Okay? You cannot square root this one. Common mistake of pre-calc kids and Algebra 2 kids. You cannot square root, so that's stuck. You can bring down the 1/2. What is the other common mistake? There's a plus! I can somehow break it up. Is there any property that deals with addition or subtraction inside the ln? The property is addition, subtraction outside, multiplication, multiplication, division inside. This is as far as you could go. That's as far as you could go.
One more thing to it.
That's as far as you could go. Anything else? Ready, set?
2 and 3.
Oh, anticlimactic. Ready, set? Oh, dun 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 dun. Okay, more puzzles. Here we go. Set 2, 3, 4. Guys, we just finished what we should have done on Friday, but it was a minimum day, so it's okay that we didn't. But here we go, 3-4. We have to use everything that we've learned in 3-4, which is a good thing, because we have to review 3-1, 3-2, 3-3 to do 3-4. Because 3-4 says, guess what? Take all those skills that you've built with exponentials and logarithms and one-to-one properties and inverse properties and all the product power quotient properties of logs. Use it all to solve equations with exponential and logarithmic expressions. So what you're writing is all review, right? But it is the most important pieces, the most important rules for how to do 3-4. 3-4 says we're going to give you lots of equations. They're going to have logarithmic pieces and or exponential pieces. Use all the rules that you have practiced to see if you can solve for x. So the whole rest of the chapter was just a training ground. Just get you the fundamental skills. So now go for reading. You guys get your head moving? High School Musical, isn't it? Yeah.
I thought it was soft.
Game 10. Another High School Musical?
I think it's like
Really?
future, like the
Yeah, it makes sense. It was a popular franchise, so I want to keep doing it.
Yeah, they just want the money.
first ones that get wrong.
You ready? Oh, a couple more seconds, people are still getting it. Ready, set, equations, what are they gonna, oh, nope, another 30 seconds, sorry. Sorry. Now we're ready? So, kiddos, even though it's a little bit illegal, it's not as illegal as up here. Whenever the one-to-one property shows up, we ignore the base, ignore the log, right? That's the one-to-one property. We ignore. What's the difference between one-to-one and inverse? What do inverse properties show us? Not just how to ignore, but how to cancel. A to the power of log base A cancels out the exponential and logarithmic, and all you have left is the argument. Log base A of a to the x cancels out the log and the exponential, and all you have left is the argument. So one-to-one property you can ignore. Inverse property is how you cancel out. If you have a log base A, you want a to the power of. If you have an a to the power of, you want log base A. Whew! These are easy ones. I would, but they shouldn't be hard. I'm not going to start solving yet. I want you guys to write them, skipping, you can like column them if you want. I would skip those 2 lines underneath them though. Get ready because we're going to go fast. So get the examples down. You could probably even make columns of 3. So we're going to solve straight down. Get them set up. And once you have them all written, if you want to start trying to solve, you may. Some of you might even be able to mental math, but these are the easy ones that you might have seen from 3-1 to 3-3. Harder ones are coming. This is just warm-ups. Just getting a little warmed up. Once you write them all down, if you want to start solving, you can. I think I took out E for some reason. I think I wanted it to be all nice and symmetric, so I didn't do that. Is that the odd number? Okay, ready? I'm going to call out random names, and if you have an idea of how to start, tell me how to start. Otherwise, just say pass. Sound good?
Sounds good.
All right, Jonathan, what do you think? Letter A, what should we do? Oh, he said pass. I didn't hear you. Sorry, Ryan, what should we do?
You just Well, it's just 5, isn't it?
Why?
It's just 5.
Why?
Because 2.
Are you kidding me?
Because 2? Really?
Because 2 to the 5th power is 32.
So we have to break down 32 into how many powers of 2?
So what do you want?
It's okay, you got the answer, and I'll explain why. We're good, sometimes we work in teams, right? Speaking of the game analogy. So, we have 2 to the x is equal to 2 to the 5 by the 1-to-1 property with Ryan right. Yes. Letter B. Colby, what do you think?
Pass.
Okay, how about Abby? How about other Ryan?
Pass.
Thomas.
How about Thomas?
It's just 3, because 3 minus 3.
Yeah.
Minus 3 minus 3 is 0.
Ooh. But who can show another way of getting there? Thomas is totally right. It is x equals 3.
The division property.
You could do division property. That's going to be messy, though. Couldn't you just move this to the other side and use the 1-to-1 property? X must be 3. Now wait, someone did say quotient property. That is a way to go. So sometimes there's more than one way to get to a solution. So question, if someone had gone quotient property, would they have eventually gotten there? How would you get rid of ln? E to the ln cancels, you get x over 3. What's e to the 0? What does x equal? Is there any shame in going about it the hard way? No. Both ways are good. And some of you just looked at it and said, well, what would that need to be to cancel out? Well, I guess it's 3. And you were right. There were actually 3 different ways to do that problem. Letter C, Janelle, any ideas? How about Kevin, any ideas?
I mean, you can change the 9 to 1/3 to the power of that negative. Wait.
You can. Can you think of a way that might not be as hard for people to grasp? Okay, hold on. Kevin said you can change 9 to be 1/3 to the power of -2. Is he right?
Correct.
Yes. Because 1/3 squared would be 1/9, and the negative would flip it to be 9. Technically that's right, but that's an awful big jump. We can see the answer should then be x equals -2, right? Does anybody have another way of finding that? Instead of making 9 to a power of 1/3, what would most of our brains make 9 a power of? 3. Okay, then pause. What can we do over here with the 1/3? 3 to the -1 to the x. Most people would jump quicker to 9 is 3 squared, but then this one, well, wait a minute, I need a 3, but he's in the denominator. Oh, it's 3 to the -1. So that means 3 to the -x is equal to 3 squared. Do we still get x is -2 in the result?
Yes.
Yes. 2 different ways of going about it. Kevin's way was perfectly right. But you could also stay with, instead of the 1/3, stick with the 3, but you have to make the 1/3 3 to the -1. Letter D, Caroline, what do you think? Yeah, you can just say the answer, that's okay.
X equal to ln 7.
How'd she get there?
Natural log of e.
Take ln of both sides, because ln and e cancel, true? So I can take the inverse, ln of e cancel, and I just get x equals ln of 7. How do I cancel out e? ln. How do I cancel out e? ln. Can anyone use the idea from letter D to try letter F?
0.
Not 0. Patricia, what do you think? What would you try in F?
Log base of 10
Yeah, and the base of common log is what?
10.
And what are you going to do with that?
You set them all as a power.
Good. You can do 10 to the power of both sides, just like we did e to the power, or sorry, just like we took ln of both sides in D. If we raise 10 to the power of log base 10, it's common log, there's an understood 10. What's going to happen to these two?
Cancel.
So So x is equal to 10 to the negative 1, and kiddos, what's that the same thing as? 1 over. Now, is there a way of going between logarithmic and exponential functions of saying base 10 to the power of negative 1 is x? Yes, but you have to memorize that property. You can also think how to get rid of logs. Well, take the base, 10 to the power of both sides. So, that should inspire us for letter G. Jack, what do you think? How would you start letter G? Rebecca? Yeah.
So you put 3 in front, and then that cancels out log 3, and then 3 to the 4th is 81.
Why is he doing 3 to the power of? What was the base? What did we do over here? 10 to the power of, because the base was 10. 3 to the power of both sides. We've canceled out the log base 3. X is equal to 3 to the 4th. Has anybody figured out what 3 to the 4th is? 81, because 3 squared is 9, and 3 squared is 9, and 9 squared is 81. You don't have to do them in order. You can just do like, oh, those squares, this one. Thanks, lunchtime. Those were easy. Warmed up, let's go. Pause, don't write this down. All of them used one-to-one and inverse properties. All of them basically used one-to-one and inverse properties. But did we talk about how there might have been more than one way to get to the answers? Yes. Okay, let's see where we're going. Do you want me to show you a problem first?
No. I want to learn cold.
Those two don't want to see it. Close your eyes for 3, 2, 1. Okay. Not too bad. You need to do 2 pages. Close your eyes.
Okay, that one.
Okay, pause. Let's write down a couple more strategies besides the one-to-one property and the inverse property. A few more strategies. The first strategy is if there's extra stuff beyond the exponential and or log, try to get the exponential and or log by itself. Ultimately, you're trying to get x by itself, but first, if there's lots of extra stuff, get the exponential or the log by itself. Isolate it. Number 2 says, look to use the one-to-one property if possible, because it's the fastest one. If you can get the logs to match on either side or the exponentials to match on either side, then use it. It's a great property. You can ignore the log or ignore the exponential, but otherwise, if you can't use the one-to-one property, you're going to have to use what we did on the last 3 examples of the warm-up of the simpler equations. If you have an exponential piece, you are going to have to use logarithmic properties to undo to get to x. At which point you can take log base a of both sides, which will cancel out the a, which will undo the a. So if you have an a to the x, and you need to get to the x, you can go ahead and take log base a of both sides. And when you do, the log base a and the exponential cancels, but what remains, guys? What's left over? The log base a will cancel, but who's still there? Yeah, the other side is still there, and also who's still there? You'll still have the x, which is what you need. But what if you have a logarithmic piece? What are you going to have to use instead? An exponential. So you have to raise a to the power of both sides to cancel out the log. What's going to remain? The x. So using the inverse property, it's not going to be there staring at you. You're going to have to make it by either taking log base a of both sides or raising a to the power of both sides. So either one-to-one or the inverse. But it might not be there for you. You might have to make it, like we did once again in the last 3 examples, We had to get rid of the e, we had to get rid of the log, and we had to get rid of the log. Okay, a couple more seconds. To be honest, kiddos, that's the last few we're writing down this page. Oh, sorry, it keeps on. We only have, if you look at the rest of notes, purple marks the homework assignment. Do you see any more notes from these pages?
They're all examples.
They're all examples. We'll do some today and some more tomorrow. Let's get in at least a page or two of examples. So here we go. What can I use for letter A? Can I get all the exponentials alone? No, they're all over the place. Okay, fine. Can I use the one-to-one property? Yes. So what can I do? Ignore. The e to the power of, it doesn't make a difference. How do I solve? Get everything to one side and factor. I know I did it fast, but it's factoring. You can write it, trust me, and you can take time when you need to in homework. Double check -4 and 1 makes -3. Good.
Ooh, letter B.
Can I isolate?
Not yet.
Are you sure?
Yeah.
Who's the exponential piece? This guy, right? Can I get the exponential piece alone? Yeah. By? Get it alone first. Before you think of anything, get it alone first. Divide by 3. Now you have 2 to the x is equal to? Close. 14.
Oh.
How do I get to x? I have 2 options, but the one that I showed you on the page before is take log base 2 of both sides, right? Because what do I have left? Now just a quick heads up. If you have to put that in your calculator, you'd probably go to common log or natural log. And sometimes the book just goes there anyway, because to be honest, log base 2 is messy when you're doing by hand math. LNs, believe it or not, is better. But technically both of these are right. This one is right, and so is that. Why do we do that? Because we can't make 14 a base of 2. 2 to a power is not 14. We could make it 2 times 7, but even then it's just going to be a different form. So what are we going to do on these ones? How do I undo an ln? Exponent of e. So what's going to be left? Leave it. Don't do a decimal. That's gross. Ooh, but what property do I get to use for that one? So I can just say 5x minus 1 equal to x plus 7? This isn't bad. I only have 5 more pages of notes here tomorrow. Just examples. Radical kids. Finish 3.3. Maybe start 3.4. Just remember, there may be puzzles out of these solved. Yeah, there's everything left. Bye, everybody. Saving the notes, stopping the video. If you're still copying, I'll leave it up for a couple more seconds.